Hi, here we will discuss about thread synchronization in Java multithreading program. A single program can have two or more number of threads. Those threads may try to access the same data resource. Eventually, they can produce unexpected result due to that concurrent access. For example, you assume that we are going to have one text file, that may be a Word file or Notepad file. When a thread is trying to open this file, another thread that may try to close the file at the same time. So the user cannot open the file and also read the data, because once you open the file in the microseconds of time, another thread will try to close that file. So the user unable to read the data from that particular text file. So we need some mechanism to avoid that situation by using a synchronization concept. The synchronization is managing that action of multiple threads accessing the same data resource. Here it will ensure that only one thread can access the resource at a given point of time. This can be implemented using a concept of called monitors, that is having another term semaphores. Each object in Java is associated with a log, or it is called monitor. A thread can hold a log, or it will release the log based upon the monitors mechanism, that is called concurrent access mechanism. Only one thread at a time can hold a log by using the monitor mechanism. For example, in Java application, one thread can write the data onto the data structure, any data structure, that may be a stack or queue or array, etc. At the same time, second thread can read the data from the data structure by using this monitor mechanism. Here, why do we need the synchronization concept? To prevent the thread interference and also to prevent consistency issue. That means the data consistency issue. And here, the current thread operating on shared data structure must be granted mutual exclusive control to access the data, because in multi-thread programming, more than one thread will try to access the same data resource. So when you are using the mutual exclusive lock on the current thread, then we can say that particular thread is having that mutual exclusive lock. Then we can enforce the monitor mechanism, that is control mechanism, on that particular object to get that concurrency control mechanism. So which is enforced by using the mutual exclusive lock. And when a thread is entering into the synchronized method or synchronized block, that is called monitoring mechanism, all other threads that are waiting for the monitor, which are using the same object, should wait until that currently running thread is exiting from that particular concurrent mechanism, that is called monitor. So suppose if you are using thread 1, thread 2, thread 3, here you assume that thread 1 is alerting the mutual exclusive lock for that particular object, then these two threads has to wait until the completion of the process T1 by using synchronization method. The mutual exclusive method is here called concurrency control mechanism, which is useful to ensure the integrity of that shared data structure or data resource. When you are using the ordinary methods, that means our methods are not synchronized methods, that is called ordinary methods, then for those methods mutual exclusive lock will not be assured. That means those methods will not have the mutual exclusion control. It might lead to a race condition when the threads are competing for the accessing of CPU time. So here the race condition can be prevented by defining the methods which are accessing by competing threads as a synchronized methods. That means we are going to define the methods from ordinary to synchronized methods. So we are going to avoid the ordinary methods by defining in the form of synchronized methods. The synchronized methods are an elegant variation of a time-tested model that is called inter-process synchronization. Once a thread is inside a synchronized method, then other threads cannot call that same synchronized method by using the same object. So they have to wait until the completion of the currently running thread inside the synchronized method. This can be implemented by using concurrency control mechanism, which is very simple because every object in a Java has its own implicit monitor which is associated with the object. If a thread wants to enter an object's monitor, that means concurrency control mechanism, then just it has to call the synchronized method over that particular object. Once they are calling the synchronized method or synchronized block, then that particular object will get the monitor or lock for enforcing the concurrency control mechanism. In Java, already we have seen that every object is having the lock or monitor. That lock will be enabled by using the synchronization method, which is allowing only one thread to access the action part of that code. Here we are having different types of synchronization. One is mutual exclusive synchronization and another one is cooperation, or another terminology is called inter-thread communication. In mutual exclusive synchronization, we are having three more categories, subcategories. One is synchronization method. Here the syntax is given. The method should be having the name synchronized keyword and the synchronized block. That means whatever the number of lines we are writing inside the curly braces, that is called a block. So this block of lines going to be defined inside the synchronized keyword. So here we will define synchronized keyword, then we will have some object here, then we will have some number of statements inside the curly braces, that is called synchronized block. Then we will have static synchronization approach. So in these three subcategories we can achieve the mutual exclusive control mechanism. And the synchronization methods in subclasses use same locks as their parent classes or superclasses. The syntax for the synchronization method is given here. The action portion always in thread concept will be written in the form of run method. Once we call the start method for any thread, then automatically implicitly the run method will execute. Inside that run method we have to use any one of that approach like synchronized block or synchronized method or static synchronization. Here we are carrying the object over the synchronized method, then that object is calling the method, that method name is withdraw, then which is receiving the amount 500, that is integer or string, whatever user requirement, then they can use that to pass as a argument value in the method. That method is inside the synchronized block, so that synchronized object is receiving the value from that particular method. Thanks for watching.